So today we're talking about how blockchain is changing the food industry. And just to recap a little bit, yesterday we talked about the romaine lettuce problems with E. coli that have been happening recently. And we talked about the 2018 outbreak specifically and how there were a lot of people that got sick. There were 36 states that were affected. 5 people died. We looked at this traceback diagram that showed us the complex supply chain involved in getting lettuce from the field to the consumer and all the people involved in that. We looked at how it was hard to do this traceback exercise because the lettuce came from a lot of different places and it was mixed together, and the records were paper or handwritten. In 2018, no digitized records, paper or handwritten. Sometimes the records didn't even exist. We looked at a bunch of images of the consumer's experience in the grocery stores when they're purchasing these products, and how there's some more information being provided about where the products are grown or when they were harvested, but it still is not answering the question immediately of whether or not the food is safe to eat. And so because of that, the FDA is recommending that we start using some new technology to address that problem. And so that is what we're going to talk about today with blockchain. So today I want to help us understand what blockchain is at a basic level so that we can understand how it helps this problem. So first, a little bit of humor. So I had some alternate titles for this presentation. One I used for yesterday, Romaine Column, Blockchain to the Rescue. Another one was Blockchain Addressing Salad Safety. And the other one, How Blockchain Will Let Us Put Foodborne Illness on the Chopping Block. So I thought those were clever. Okay, so blockchain really at a basic level is about data. It's just a way to store data. And that data can be anything. It could have to do with food traceability like we're talking about today, or it could be like an account balance with digital currency. It could be any type of data. And I find that the easiest way to help people understand some of the things that are unique about blockchain is to compare it to a traditional database, which is how we typically store data today. And so there's 3 ways I want to compare it to the technology that most of the world is using today so we can see what's unique about it. Okay, so the first thing that's unique about blockchain is that it is distributed. And what that means is, I want you to look at that little picture in the bottom left-hand corner. So that is how a traditional database is structured. There's a centralized point in the middle, and there's all these people that read from that data or that write to that data. And really how it works is there's a central place that is administered by a person or a group of people who are in charge of that database, and then everyone else has to read from that same source. And what that requires is trust. It requires that you trust that person or that group of people that is in charge of your data, and you trust that that physical location or that remote server where that is being hosted is going to be online when you need it, and it's not going to have failed or something like that. Compare that to blockchain, and blockchain is a network of peer nodes that each store and administer the data. So when you look at a diagram, it looks different. There's a lot of dots, and each of those dots have the data in them, and they're being maintained. Each dot is being maintained by a different group of people, but they're all linked together and they're synced together so that they still are showing the same picture of that data. And so that doesn't require trust. You're not having to put trust in one central location or person. Instead, it requires something called a consensus algorithm, which is just a fancy word for some rules. So consensus algorithm, it's really the set of rules that allows the blockchain to remain consistent. So when people transact on the blockchain, and transacting on the blockchain just means working with it, adding data to it, each of those little nodes is doing that on their own. So they need to make sure that they all agree on what the truth is, that that one of those nodes isn't thinking something different from the other one, because then that's not valuable. We've got different data spread around. The consensus algorithm is just a set of rules that lets us decide on what truth is, and that is defined ahead of time, and then that allows the data on the blockchain to remain consistent and accurate, and also protects against malicious nodes or people trying to hack it, right? It protects against someone trying to change the data and pull something on the rest of the group, because if they don't follow these rules that are defined, then it'll be considered inaccurate and it won't get recorded in the blockchain. Okay, so that was distributed. That's one way that it's unique. The next way is immutable. And immutable just means unchangeable. There's two ways that the blockchain is immutable or unchangeable. One is it is append only. And so again, comparing it to how databases work today, there's this acronym CRUD. It means create, read, update, and delete. And those are all the things you can do on a traditional database. So, you can add a record, that would be creating. You can read from it. We know what that means. You can update it, which is just changing some data. And then, of course, you can delete data. So comparing that to a blockchain, it's only the CR of that. So you can only create and read. You can't update and you can't delete. So sometimes people think, well, wait a minute, what if something gets on the blockchain that's not right and I need to change it or something? Well, you wouldn't actually update it. You would just add to the blockchain. You would create a new record that says, hey, this record from back in a couple days ago was wrong. I'm appending another record to add more information, but I'm not going to go back and change that previous record. So the record of the mistake would still be there, but you would add information saying that this needs to be corrected. Okay, so another way that a blockchain is immutable is that it's cryptographically linked. That's a long word. We're going to break that down a little bit. So really what this is talking about is the block and the chain part of blockchain. What is the block and what is the chain? So the block is a group of transactions along with something called a hash. So let's break this down even further. So a transaction is the data that you're wanting to store on the blockchain. It could be anything. So in this example, it's some payment information that Alice is paying Bob $20, and then some more important data, more data, any data. It's any data you want to record. These are your transactions. And so these transactions are run through something called a hash function, which spits out a unique number. So this is the actual hash of those data points. Those things actually turn into this through a certain hash function. It's this long number that's unique, and it's computed from those letters of the data that I just showed you. And if you were to change one letter, like Alice pays Bob $20, if it was like $30, instead you've just changed one digit, this number would be entirely different. So that's a little bit how that works. And so bringing it back to the block, so the block on a blockchain is a group of your data, your transactions, and the hash of those transactions. So it's kind of like a code that represents that data. Now the way it turns into a chain is that in addition to having a hash of itself, each block actually also has a hash of the previous block. So what this means is that as you add to the blockchain, they are all linked together. And if you change something or try to change something back farther up in the chain, then it's going to change all of the blocks down because it's going to cascade down. It's going to change the hash on that one block, which would change the next block and next all the way down. So what that does is makes it apparent if someone's trying to change the data, which is not allowed. You're not allowed to change the data, right? So if someone's trying to tamper it, it becomes immediately evident that they're doing that. And so that's what helps to keep the integrity of the data on the blockchain. So that's the block and the chain. And that's the immutability of blockchain. So the final way that blockchain and traditional databases are different is that blockchain is transparent. So a traditional database, it will show us the current value of something. So for example, it'll say that Bob has $100. Okay, well that's useful information, but why does he have $100? How do we know that's true? Well, we don't really, because that's all the information we have. But with blockchain, it shows us the entire history of transactions that make up the current value. So instead of just Bob has $100, we're going to have the fact that Bob created an account, and then he received $50, and then he paid $30, and then he received another $80, and we can compute from those transactions the fact that Bob now has $100, and now we know why he does. So we don't have to just trust that that balance is recorded correctly. We can see the reasons why. Okay, so just to review, we've got blockchain versus a traditional database. A blockchain is distributed. There's no single point of failure or trust, while a traditional database has a single point of failure and trust. Blockchain is immutable. The data can't be tampered with, while a traditional database, we saw it has all those CRUD operations, create, read, update, and delete. So the data can be changed or deleted. And a blockchain is transparent. It's a complete history of records, while a regular traditional database is more opaque. It's just kind of a snapshot of the current value that may have been changed in the past and will probably be changed in the future. Okay, so that was a lot of computer science-y stuff, I feel like. Let's take this back a little bit and look at it with a more practical analogy. So I like to think about blockchain as a notebook. So if you don't remember anything else about how blockchain works today, this would be a good thing that you can remember and maybe explain to someone. So blockchain is like a notebook. And the reason why it's like a notebook is because a notebook is made up of pages, right? And so you can say those are like the blocks on the blockchain. So what do you have on the pages of a notebook? You have transactions. You have your data. You're writing on it, right? And I put here a picture of a permanent marker because, again, a blockchain can't be changed or deleted, right? So it's like you're writing in permanent marker. So you're writing in permanent marker on the page of your notebook, and then the hash is kind of like the spiral binding that links those blocks together. So if you think about one of those spiral-bound notebooks, and if you try to tear a page out of it, you can see that there's evidence that that's been done because it leaves behind the little pieces of paper, right? Some of them have those nice perforated lines, I guess, but in this example, you're kind of ripping out a page and you're leaving some traces behind. So that's kind of how the hash works that we saw. The hash links the blocks together in the blockchain, and it makes it so that if you try to change something, you're going to know immediately that someone's trying to change this data. Okay, so a blockchain network then is kind of the bigger picture. This is the diagram that I showed earlier in green where there's those little dots that were all connected. So think of a blockchain network like a classroom of people where you each have your own notebook and you're all copying off of each other. So as soon as someone writes something in their notebook, everybody's looking over their shoulder and they are then writing that exact same thing down in their notebook. And so everybody's notebook says the same thing. That's kind of how a blockchain network works. Okay, so blockchain as a notebook. Hopefully that kind of like puts it in perspective a little bit and helps to explain some of those deeper computer science concepts. Okay, so now let's go into the types of blockchains. There's a few types of blockchains, and there's two kind of divisions that we talk about with blockchain. Public versus private, and that refers to who can see the data on the blockchain, and then permissionless versus permissioned, which refers to who can transact or who can write their data on the blockchain. So we're going to look at a little breakdown of these, kind of a little grid where I have examples of some of these kinds. We'll start with the top left where we have permissionless and public. So this is the traditional original blockchain. Anyone can transact and anyone can see the data. It's wide open. Okay, and there's two really big examples of these I want to talk about. One is Bitcoin. So we heard this mentioned a little bit yesterday, and you hear this in the news all the time. So Bitcoin was started in 2008 by a person or a group of people named Satoshi Nakamoto. So this person or group of people, their identity is actually unknown. They just wrote a white paper explaining this blockchain technology and put it on a forum online. and it kind of like grew from there, but no one actually knows who invented this, so it's kind of a cool mystery. But this happened in 2008, and it was the first use of blockchain technology, and it was a digital payment platform with its own digital currency called Bitcoin. Second example of a completely open blockchain would be Ethereum, and this was started in 2013 by Vitalik Buterin. And this introduced the concept of smart contracts, which you will hear sometimes when people are talking about blockchain. Smart contracts are just code that is stored in the blockchain. So we talked about how you can store any type of data in the blockchain. Well, you could also store code that could then be run. So it's a way of storing logic in the blockchain, and it can be used to automate processes and really any type of logic that you want to have run on the blockchain. So this made blockchain go from just being a place to store data to an actual computing platform that can act upon that data by logic that you're also storing in it. And it's powered by a token called Ether. And that token is also traded like a currency like Bitcoin. So there's a lot of different examples of these that are being traded today, and their values are they fluctuate a lot, and it's pretty interesting to follow. So that's kind of the public permissionless area of blockchain. The next one is public and permission, and this is kind of a hybrid. So only authorized people can transact on these type of blockchains, but anyone can see the data. This doesn't have a lot of practical applications yet, and it's kind of outside of the scope of what we want to talk about today, but this does exist, and we could see more uses for this coming in the future, but I don't want to focus too much on it. Same with this bottom left corner. This is kind of the opposite. So it's anyone can transact, but only authorized users can see the data. One example I think of with this is like a voting application where anyone can vote, but only certain people can see the results of that voting, perhaps. Again, there's not a ton of uses for this yet, but what we're here for today would be this bottom corner. This is private permissioned blockchains, and this is also known as blockchain for business. If you think about what I talked about earlier with Bitcoin and Ethereum, how anyone can transact on there and anyone can see the data, it's completely wide open. When you think about it, taking that and applying it to business, it doesn't really make much sense, right? Because businesses have the need to keep some of their information private and to know who's accessing it. And so that's where this type of blockchain comes in. So only authorized people can transact on it, and only authorized people can see the data. Some people say this isn't a true blockchain because it's kind of a different paradigm from that original blockchain we talked about, but I still think it is. So, okay, so a good example of this is Hyperledger. And this was a project started by the Linux Foundation in 2015, and it's geared towards efficiency for business use cases. And there's no token with this because of how this logic works and how it's set up. There's no concept of cryptocurrency being traded in relation to this type of blockchain. That's one of the things that's a little bit different. We talked about how you need a consensus algorithm to ensure that the blockchain is consistent, right? And part of the logic of how that works has to do with tokens. And because of the way this is defined, you don't need tokens. So it's kind of a different concept. You're not going to be hearing about trading Hyperledger tokens and making millions of dollars with that. This is different. It's an architecture that allows you to set it up for your business use case. So let's take a look at a couple of interesting examples of people using this platform in the agriculture industry, in the food industry. So the first biggest one is the IBM Food Trust project. And so you can see all of these logos up here. These are some really big names, right? And all of these companies have signed on to this IBM Food Trust project. And again, that's built on the Hyperledger blockchain. And what this really is a cooperative network of companies and this technology platform that's focused on food safety. And so I want to talk about a couple of applications that these companies are using this platform for. So the first is Carrefour. Carrefour is a French grocery store, and they are currently using the IBM Food Trust to track over 20 items that they sell. There's chicken, eggs, milk, oranges, pork, cheese, tomatoes, lots of different items that are being tracked on this blockchain. And the way that they're exposing the data to the consumer is through QR codes on the packages. So you can pick up a package in the store, scan it with your phone, and it'll open a link that will show all kinds of information about that product. For example, for their chicken, if you scan their chicken package, it shows who was the farmer that raised that chicken, what were they fed, whether or not they were treated with antibiotics, information like that, just right with the ease of your smartphone right there in the store. Okay, the next example is Golden State Foods. So this company is the beef patty supplier to McDonald's, and I believe some other restaurants as well. And they are using blockchain to track beef patties kind of through the supply chain from a production facility to a distributor and to the restaurants. And what's really cool about this is enabling some better sharing of data and working together, so the distributor can see the inventory at the restaurant because they're all logged into the same blockchain system. The distributor knows and can anticipate what this McDonald's restaurant is going to need and can better deliver on that, can have the supplies ready, and can just anticipate what they're going to need better. Another cool thing about this is the use of RFID tags and temperature sensors that they are using to prove that the beef has been kept at a certain temperature. So essentially these sensors are IoT devices, Internet of Things devices. So these sensors are uploading their data to the blockchain and are proving that while this beef is in the facility or in a truck or sitting anywhere else, that it is being kept at the correct temperature. And then this information is shared on the blockchain and can be verified by the restaurant so they know they're getting the quality of beef that they're paying for. Another example is Walmart. Walmart did a test case a couple years ago where they wanted to track a package of mangoes from in their store, and they wanted to track and see what farm it had come from. And it took them 7 days to figure that out using their traditional means, which was probably some paper records like we talked about yesterday. But once they implemented this blockchain solution with the IBM Food Trust project, it was reduced down to 2.2 seconds because all of those records were digitized and shared and just dramatically increased that efficiency of that traceback. And so because of that, they have implemented a leafy greens initiative, and they required all their leafy greens suppliers to join onto this IBM Food Trust project by September 30th of last year. And this was huge. This is an example of Walmart using their power in the marketplace to help onboard people to blockchain. I wasn't able to find any updates yet as to how this has gone, since this was late last year that they were supposed to comply with this. But it's going to be interesting to follow this situation and see whether or not Walmart has been able to get these suppliers to join in, and if that's helping at all with any future issues that might arise. Okay, so that was the IBM Food Trust. There's another project under this Hyperledger technology that's worth mentioning. It's not as big, but it's the SAP Blockchain. And they still have some big names on here, right? Kellogg's, Blue Diamond, Target. Let's talk about a couple of these examples too. So BUMBLEBEE, the tuna company, is another one. Similar to Carrefour, they are using QR codes on their tuna cans to share data about that tuna to the customer. So the size of the catch, the actual fish that was caught, is, you can look that up. You can see where it was caught. You can see the fair trade status. So, you know, the compensation to the fishermen and certifications surrounding that. And then Nate, I believe is how you pronounce that, is a popcorn company, and they're doing the same thing. QR codes on their packages, exposing the quality, variety, weight, and even the field where the popcorn was grown. Okay, so those were some examples of blockchain technology in the food industry, but I want to look at a little bit bigger picture of what's possible that maybe is not, we don't have concrete examples happening today, but things that will be coming. Blockchain and food. So there's really two main ways that I see blockchain and food working together, and that's traceability and supply chain efficiency. So traceability is going to be enabled by some of these properties of blockchain that we talked about earlier. Transparency, the fact that you can see why there's a certain value. You can see all the transactions that led up to that certain value. Decentralization, the ability to have multiple people, just like your question, share their data in a way that works for them, and coming from different locations, but all being worked together and synchronized. And then immutability, that idea that the data can't be changed or tampered with after the fact. So that's going to enable traceability for a few different examples. So food safety, we've talked about this a lot already. It's going to help us find the source of a contamination quicker because we can trace it back quicker, which is going to help us stop the spread of disease faster and reduce waste. So in the example of the E. coli outbreaks in lettuce, there were points where they just said, throw away all the lettuce. But really, not all of that lettuce was contaminated. So that was a lot of food waste. But they weren't able to figure out which lettuce was the problem and which was safe. And so hopefully with better traceability, they'll be able to distinguish that. And I think we're seeing that even with the outbreak that's going on in this area, that they were able to recognize, okay, it's just the lettuce grown from this certain region in California that's affected. And so I think we've had romaine lettuce a couple times here at this conference, I think. And so obviously they're able to identify that there's still some safe lettuce out here to eat. So anyway, we're seeing improvements with that. Okay, so the other way that traceability is going to help the food industry is through certifications. So basically, it's the ability of food producers to communicate and prove the value of their food to consumers. So if you look at all of these little icons, we see these on our food packaging a lot, right? And they speak to different levels of quality, different attributes about our food, and different things consumers are looking for. Whether it's organic, halal, gluten-free, we want to know that these foods are meeting certain processes to be able to get these certifications. And it's great when there's a label on our food that says that, but how can we trust that that's actually what happened to the food, right? And so that's what blockchain is going to enable, because you could scan a code on that food item and you could see evidence of that process, whatever that looks like. It could be photo evidence, it could just be information about the supply chain that's going to help prove that certain processes were followed. It could be some sort of certification, like the USDA issues an organic certification, and you can view the actual document or something about that. But consumers these days are really looking for these types of things, and so it's going to be valuable for producers to be able to prove that. And so I want to share a little video clip that kind of talks about the mentality of consumers today.
Hey guys.
Hello.
Hi, hello.
My name is Dana. I'll be taking care of you today. If you have any questions about the menu, please let me know.
I guess I do have a question about the chicken, if you could just tell us a little bit more about it.
The chicken is a heritage breed, woodland-raised chicken that's been fed a diet of sheep's milk, soy, and hazelnuts.
Okay, this is local?
Yes, absolutely.
I'm gonna ask you just one more time, and it's local.
It is.
Is that USDA organic or Oregon organic or Portland organic?
It's just all across the board, organic.
The hazelnuts, these are local?
How big is the area where the chickens are able to roam free?
I'm sorry to interrupt, I had exactly the same question.
4 acres. Give me just a second, I'll be right back, okay?
Okay.
Okay.
Great.
She's nice, right?
We're doing the right thing.
I'm too apologetic.
You are.
I drove way too slow here today, didn't I?
Yeah.
I am so weird with that gas pedal. It just moves the whole vehicle forward.
All right, so here is the chicken you'll be enjoying tonight.
You have this information. This is fantastic.
Absolutely. His name was Colin. Here are his papers, okay?
That's great. He looks like a happy little guy who runs around. A lot of friends, other chickens as friends. Putting his little wing around another one and kind of like palling around.
I don't know that I can speak to that level of intimate knowledge about him. They do a lot to make sure that their chickens are very happy.
When you say they, I mean, who are these people raising Colin?
It's a farm that's located about 30 miles south of Portland.
And you feel, like you have a good relationship with this farm?
We do.
But is that some guy on a yacht who lives in Miami?
Oh,
who's
goodness,
just
no.
saying that he's organic?
It tears at the core of my being the idea of someone just cashing in on a trend like organic.
No, I know the type, no.
Yeah.
Tell you what, we're gonna go check it out if you don't mind. Just if you could hold our seats.
Oh, no.
Yeah, and we'll be right back. Just want to make sure.
Just, you know, thank you so much, Dana.
Sure. Okay, that's pretty hilarious. So that's from the TV show Portlandia. I haven't seen much of that show, but I did grow up outside of Portland, and I feel like it rings pretty true. Yeah. So you maybe you don't want to see a picture of the chicken and know his name and all that, but consumers these days really do want to know a lot of information about their food. So again, being able to show that and prove that is going to be a huge value. Okay, so the other way that traceability can help is with food fraud. So food fraud it refers to substituting, mislabeling, or diluting food, and it's usually for financial gain. Telling consumers you're selling one thing, but that's actually not what you're giving them. And other than just ripping people off, basically, the other concern for this is there's health concerns. If people are getting a product that's not the product they were thinking it was, there can be concerns with that. So a couple examples of food fraud incidents that have happened lately. One, a few years ago in Europe, there was a horse meat scandal. So the Irish Food Safety Authority did I think it was just some routine testing, and they found that in 1/3 of the samples they tested, it was actually horse meat instead of ground beef. So of course this led to a lot of testing all over Europe, and actually 13 countries found horse meat in their beef, and some burgers were 100% horse. Okay, so if you think about what it takes to pull off a scam like this, somewhere along that supply chain, somebody changed some information or just made up some information. They didn't have anything to prove that it was beef or that it was, So they were able to pull off selling horse as beef, right? And so if we look at blockchain technology and these solutions that require some proof, they require that we're entering little bits of data along the supply chain. It's going to be a lot harder to perpetuate a scam like this, because all of a sudden you're not going to have the proof, like things aren't going to line up, and that's going to be apparent. Or if you try to change something, everyone's going to know, right? And so this type of thing is going to be a lot harder, especially as consumers are expecting that kind of traceability information and they don't see it on a product, then they're not going to trust it, and they're going to realize something like this could be going on. Okay, another example of food fraud. There's a lot of food fraud with seafood. There was a study that came out a few years ago. They sampled 1,200 different products in some grocery stores, and they found that 1/3 of the samples were mislabeled. So people were basically paying a higher price for fish of a lower quality. And this is where the health concern comes in. Some of this fish had mercury, high levels of mercury, which can be a health concern for certain people. And they thought they were getting a different type of fish that didn't have that. So pretty surprising. A final example is honey. I watched a Netflix show about this. I'm trying to remember the name of the series, but there's a series kind of about food on Netflix, and this is where I first learned about this example of honey. But I guess the demand for honey all over the world has grown so much in the last few years that beehives can't keep up with it. And so the market has been flooded with a lot of fake honey. A lot of it comes from China. It's made from corn syrup or rice syrup. The interesting thing about this is that in the US, a lot of the honey that we eat is clear, and the way that they make it clear is they remove pollen from it. And I guess it's just to be more aesthetically pleasing. We like the look of it better, right? But what that does is removes the ability to trace the honey back to where it came from, because pollen is going to have a signature, if you will, of where in the world it was grown, the actual plant, right, that it came from. And so with blockchain, we could expose some of this. We could actually be able to share that location of where that honey was grown and kind of prove some of that and prove that value to customers so they know they're getting real honey and it's not corn syrup. I wonder how much corn syrup I have eaten in honey, probably a lot. I've heard the same thing about olive oil, actually. It's faked a lot. I've even heard it said that people living in the US haven't really even had real olive oil. So I don't know how true that is, but it's surprising. I think there's a lot of this that goes on, and blockchain's going to enable us to get some visibility into the people that are actually selling what they say they're selling. Okay, a final way that blockchain and food can work together is supply chain efficiency. So it's a pretty simple concept. Just the fact that we're going to be sharing more data from different parties in the supply chain is going to help us become more efficient. One way is smart contracts. We talked about those being just some logic that is coded onto the blockchain that can help us automate some processes. And again, the transparency of being able to see all the data. It's going to help us make decisions quicker and work together better. One way is payments. So like we talked about, the origins of blockchain technology were with the Bitcoin project, which is a digital currency. And there's a lot of applications of blockchain technology to payment. They make international payment a lot faster and cheaper than the current way of doing it, where you have to use a bunch of banks and your money just jumps from bank to bank all over the world, and each one of those banks takes their cut, right? With blockchain-enabled payment platforms, you get a lot less fees, a lot fewer people between you and who you're trying to send money to. And smart contracts can be used to ensure payment. So if you put some logic on the blockchain that once a product is delivered or once it meets a certain level of quality or something, then you can automate payment to your provider. So things like that can help to streamline payments. Another way is just sharing data, real-time records, reduce the need to send paperwork back and forth. That just speeds things up. We saw in the E. coli investigation that they were tracing paper, handwritten documents. Imagine if it was all digital. I mean, just simply digitizing those documents would be a huge step forward, right? Let alone joining a blockchain where you can then share those things better with the proper security around them. Another example is the fact that if we start to see kind of that map of the supply chain, like that traceback diagram I showed, then we're going to start to see how many people are involved in getting our food or our product from point A to point B. And maybe we're going to recognize and realize that we don't need all those people to be involved, that there's some opportunities to cut out some middlemen and make it more efficient. But we wouldn't know that unless we could see the whole picture, and blockchain would help us see that picture. Finally, logistics, real-time food tracking. This was kind of the example of Golden State Foods with the beef patties that we talked about earlier, just the fact that we can have sensors and real-time tracking, and we can improve our decision-making because of that. So being able to send food to where it's needed more efficiently and not have food going bad in one place while it's needed in another place, just being able to monitor that in real time can reduce food waste and improve efficiency a lot. Okay, so that's really it. That's my vision of how blockchain is changing the food industry. I think there's a lot of exciting possibilities coming up. I'm sure you've probably had some ideas as you've listened today, but I think that's all I have. Cool, thank you.
Well, thanks, Erin.